Hello and welcome to the second question in our little series of ones looking at doing simple binomial questions. This question concerns a woman, Trina, who takes the train to work. She claims that the probability that the train arrives on time is 0.4 and that the train's arrival is independent from day to day. Assuming her claims are true, determine the probability that the train arrives on time at the station 3 days out of 2 weeks and on no more than 10 but fewer than 20 days in an 8-week period. First question, can we do this using the binomial? Okay, so there are 4 criteria to meet. Firstly, is it independent? Yes, it says so in the question. Does it have a fixed probability of success? Yes, it says it's 0.4 in the question. Are there 2 possible outcomes? Late or not late, so yes. And finally, is there a fixed number of trials? In the first question, yes, there are 10. In the second question, yes, there are 40. So we can use the binomial. For question A, we can set up a binomial model where x is the number of times the train is late, and that can be modelled as a binomial. And in the first question, A, there are 10 trials with a fixed probability of 0.4. We're interested in the probability that x is at most 3. So that's x is less than or equal to 3. And now we need to get the calculator up and use the calculator to do this. So again, we need to set the calculator into the correct mode. And we choose number 7. And this is a binomial CD because we want it to be less than or equal to. It's a cumulative one. And we know the value, it's 3, so we choose variable from the options there. So x is 3. The number of trials is 10. And our probability is fixed at 0.4. Okay, now we just need to press equals to get it to calculate for us. Okay, and there's our solution. 0.3823. So that's the solution for part A, 0.3823. That's fine, that's finished. I'm going to clear the screen and we'll look at part B, which requires a different binomial model. So part B, this time, we got an 8-week period rather than a 10-day period in the previous one. So our model in B is going to be that x is again a binomial, but we this time have 40 trials, 5 8s, 40. Our probability is still fixed at 0.4. Now we're looking for the probability that x is in between 10 and 20, not inclusive. Okay, so if we consider what that would look like on a scale, the number line, we'd have not all the numbers up to here, then we go 9, 10, 11, miss out a few numbers, 15, 16, 17, 18, 19, 20, and so on. So the question is asking us to find the numbers up to 20 and more than 10. So it's this section here that I've highlighted in blue. That's what we want to find, but the calculator can't do that directly. So we are going to work out the probability of up to 19 and including 19, and then we will subtract all the ones that are 10 or less, and that'll leave us with the right value. So what we're saying is that this is equal to the probability that x is less than or equal to 19 minus the probability that x is less than or equal to 10. And we need to find both of those values on the calculator. So let's bring up the calculator and have a go at these 2 questions, these 2 calculations, then we can get to the final answer. Okay, so once again, we need to set the calculator into mode 7. And we're choosing the CD, because we want the less than or equal to. And we know the numbers, so choose variable. Okay. Our numbers here, we need to put in 19 first, because that's our x value. We want 40 this time for the n, and the probability is still 0.4. Okay. Do that, get a calculation, and we find that that value is 0.8702. 0.8702. Now we're going to repeat the process, but using the value for 10, and that gives us 0.352, 0.0352. If we now subtract those from each other, we get 0.835 as our final answer. Okay, that's pretty good. So I want you to go away and do some practice questions for yourself now. I'll be online. Ask me for help if you need it.